Okay, so this is an expository text or informational text. So we always look at the title. How birds got their beaks. So this tells us the topic. They're in looking into the mechanism or the factor that helps the birds form their beaks, which is probably the aim or the objective of the study. So, agile beaks of all shapes and sizes, from gulping gape of a pelican to needle nose of hummingbird, have enabled the 10,000 avian species to thrive. So you can see this is just background information. Different beaks, different functions. Now, researchers may have, so this doesn't show 100% certainty, may have identified genes that transform an ancestral snout into a bird's bill. So I'm going to say not 100% sure. So probably we can infer there might be controversy, right? By manipulating, this tells us the methodology. This is the context, the how, or the methodology, different depending on how they word it. They have seemingly, again, not completely certain, seemingly turned back the evolutionary clock, producing snouts and developing chicken embryos that resemble those of alligators today. And then we see the quotation, which is a paraphrase, so I'm just going to cross the whole thing out, and the qualification doesn't matter. Their conclusions, okay, so this is important, are at odds with an earlier study. So do you see how that's why we're not 100% sure? Because there's contradiction. But, strong transition, even those who disagree with the result say these two scientists, now a postdoctoral fellow, have demonstrated a powerful approach. So they do acknowledge the method, even though they disagree with the result. So what is the method? Pinning down how anatomy changes using fossils, then trying to recapitulate the changes in the lab by tinkering with the genetic signals. So that is also the methodology being proved. And again, we see the quotation, which is a paraphrase. So I'm going to skip the rest of this paragraph. Going to line 28. In ancestral reptiles, a pair of small bones makes up the tip of the snout. In today's birds, so this is a contrast juxtaposition, those premaxillary bones are long, narrow, and fused, producing the upper bill. So this is background information again. The ancient bird Archaeopteryx reveals an intermediate step. So this is the key, right? From the reptiles to the bird's bill. So intermediate meaning in the middle. So it shows us the transition. Its premaxillary bones were not very expanded, but in later avian species, the bones are progressively more fused. Other work had also implicated, meaning that there is sort of a consensus, right? There's an agreement in the field of science, the premaxillary bones in beak evolution. So this is our key to solving problem. So Buehler searched for earlier studies of genetic pathways that control development of these bones. Work in mice and chickens. So whenever they talk about work on other species, get used to make a note of it. Why? Because the inference that we can draw is that the same phenomenon or trend or application can happen cross species. Okay, that is the inference. So work in mice and chickens had implicated two sets of signals. A gene called fibroblast growth factor 8 or FGF8, so I'm going to use yellow for this one, becomes active in the front part of the face as it takes shape in 3-day-old chick embryos. Later, just before bones form, another WNT helps drive the proliferation of cells in the middle of the face. So either way, we know that based on work in mice and chickens, it's FGF8 and WNT that play the part in forming bills, where it may prompt expansion of the premaxillary bones. In mammals, lizards, turtles, and alligators, in contrast, juxtaposition, activity of the WNT gene is highest on the size of the embryonic face. So I'm going to write contrast with different species. Now, to explore these genes' roles, right, to solve the problem. So oftentimes when you see infinitive, it's probably important to do this, to do that, to explore. They treated bird embryos with inhibitors. So this is going to be procedural. Text, step-by-step action. With inhibitors of WNT and FGF8 proteins. So we can guess that they assume that these two genes help birds form beaks. So now they inhibit the two proteins. So we can probably guess that the beaks would not form. When the two signals were curbed, the bones became round, see, never fused, as in the bird's dinosaur relatives, instead of growing long and pointy. So it seems convincing, supports hypothesis. To the pair's surprise, when they're surprised, you should be surprised too. A palatal bone, which makes up the roof of the mouth, also changed dramatically. All right, so this is probably unexpected. The palatal bone changed too. In many vertebrae, this bone is flat and fused to surrounding bones, but in birds, it's reduced and disconnected, which frees the top part of the bill to move upward, expanding birds' gapes so they can open their beaks wide. In the treated chick embryos, the ones with inhibited proteins, the palate looked more like it does in other vertebrae, flat and seemingly reconnected to jawbones. So what does that mean? It suggests that these two genes allow skulls of ancient birds to evolve a whole new direction. So that is their finding that supports their hypothesis. But you see here, there is controversy. So I'm going to draw a line because we see that it's not 100% certain. Not everyone agrees. So the function of this paragraph, of course, is to challenge that. Nathan Young and other scientists, they carried out extensive skull measurements on a variety of embryonic vertebrae. So they did their research as well. That's their method. What did they find? They determined the point during development at which the bird face begins to diverge from those of other vertebrae. The work and later experiments supported a 2009 idea proposed by Mercutio. It is actually SHH that is critical, not FGF8 or WNT, right? Unlike FGF8. So unlike FGF8, he says it's active in the right place and right time in bird embryo. So there is a disagreement. Now, Mercutio also worries that the changes in facial structure observed by the Harvard team may stem from unintended cell death. So he points out the potential flaw, addresses potential concern of first experiment. So maybe not valid. Adding the fossil record to this work is really an important step, but I think they're just looking at the wrong pathway. And do you see the last sentence? We're going back to the first group of scientists and they're countering again. So it's a back and forth debate. They counter that FGF8 and SHH are often co-expressed and may work together. So they're saying that, you know what? Despite what you say, we are not entirely wrong because the two different genes can actually work together. And that is why for expository text, it's important for you to know how many groups of scientists they are, what their findings are, and whether they agree or disagree with one another. Okay.